speakers, where Jenny Hutchings from Oregon State will be giving us a rundown on the sea ice dynamics experiment that's currently happening in the Beaufort Sea, or also known as SIDEx. And we're connecting her with Walt Clark at the National Ice Center, who has been delivering products to help with this field campaign. And I think this is really at the heart of one of the Sea Ice collaboration team goals, is linking stakeholders together to have a discussion and to help promote future collaborations. So with that, thank you all for attending, and how about we get started with Jenny right now. Go ahead, Jenny.
Okay, good morning, good afternoon, everyone. Let me see if I can share my screen. That's the first trick. It's nice to see so many friendly faces on this call. Okay, so I'm representing a large group of people. This is a project funded by the Office of Naval Research, their Arctic and Global program. And my co-leads on the project are Chris Polachensky and Andy Mahoney, who have been in the field for the last month. So they haven't had any time to prepare for this talk. This is basically happening as it happens on the fly. So this project is a 5-year project, and it has had field work already in Elson Lagoon, in Barrow, near Point Barrow. We did some field work on land-fast ice, looking at thermal cracking. And last year we were involved with the Mosaic field campaign, but I'm going to focus this talk on what's happening right now in the Beaufort Sea. And the field team came back last week. Emily Fedders was on this call, so I'm going to give any questions about the experience in the field to her, because she can talk much more clearly about that than I can. I was helping from Oregon. And there's a large number of investigators on this project. CREL's involved, UAF, Woods Hole, MIT, and the University of Delaware. And we had a great team of undergrads, Jacob, Cristina, and Katie, who actually helped with weather analysis so that we could maintain a safe campaign. So we were providing daily weather forecasts with support from some senior advisors, Tom Ballinger, who had supported ICE campaigns in the isSIDex campaigns in the past, and Jackie Wichtermenger and Lou Shapiro on the ice analysis side. And we really could not have done any of this field work without the satellite data collection. And there's a large number of people who've been providing me with near real-time satellite data to support the field team. So with that, I will move on. Hopefully you've had time to read all of the team members. There's a lot of them. Okay, so in late February, Andy and Chris found this location for the camp. It was a classic ice camp in winter in the Beaufort Sea, where we needed to have a landing area on first-year ice that's next to a multi-year flow that we hope will stay intact for the duration of the field campaign. Or actually, in the case of this field campaign, we were hoping to see it break, because what we're doing is we're actually looking at cracking of sea ice and trying to relate the stress fields that's causing that cracking to the strain that is accommodating the cracking. And we're trying to understand what are the micro cracks, the smaller scale cracks that accumulate the stress and then cause larger scale cracking. So this is where the camp was set up, and it was 2 tents were pitched around about here. And we couldn't have found this field site without the help from the National Ice Center, who provided us RADARSAT-2 imagery with which we could go out searching for a multi-year flow that was situated next to a first-year ice pan. So what are we looking at? In late February, the Beaufort Sea looks something like this. This is a VIRS image. Thanks to Gina for providing it in near real time, so we can look at the ice as it's cracking in time. And we set up a camp somewhere over here, and you'll see these arching cracks. They're indicative of wind that's moving this way, and the ice is breaking along that arch. And at this time, the ice in most of the Beaufort Sea, this is the Beaufort Sea here, was very stationary. once we had a camp set up, these arches continued to work. So you can see that there's dark, this is a thermal infrared image. So that means the darker means it's warmer. And the arches started moving towards the camp as the wind maintained its direction, and the ice pack started moving off the coast of Alaska and Canada. So as that camp moves along the drift track, the black is the drift track that we've seen over the last 3 weeks, which is remarkably fast, by the way. We can see that the Beaufort Sea cracked into this pattern of cracks that were running from the southwest to the northeast. And eventually they were joined together in cracks that were running in the parallel perpendicular direction. And you can see we had deployed a lot of buoys around this camp, so we're tracking that strain that's accommodated in those cracks. And the ice pack is continually changing. Notice here that along the coast, we're seeing breakouts of landfast ice that affected the camp motion. Until relatively recently, when the ice camp was evacuated due to the flow breaking up. It was evacuated around about the time we were expecting it to, so but even so, we saw a lot more action than I would have expected if I had been on this ice camp 10 or 15 years ago. So this level of cracking that we're seeing in the Beaufort Sea is actually not so unusual when you compare it to the last 5 years of imagery, but likely an unusual event compared to previous decades, and that's something we do need to look into. Okay, so SIDEx is basically a sea ice mechanics experiment. Called it dynamics because most people think about dynamics, but our end goal is to improve ice dynamics models by understanding the mechanics. And the things we're looking at is basically, we're looking at stress and strain on the ice flow, and we're trying to determine what the nature of stress concentrators are that become large cracks. Essentially, when ice cracks, it accumulates stress at discontinuities in the ice. So previous cracks that already exist are likely causing this, or the interface between different ice flows where you have ice of different strengths. So between the first year and the multi-year ice, for example. And we can, with the data we've collected, we can answer some questions like, when are these cracks activated? So if we've identified what they are, when are they activated? Are they always the same? Okay, so are they always thermal cracks, or are there some cracks that form dynamically and then heal, and then we're reactivating those cracks? Are these different cracks activated under different dynamic conditions? And are they isotropic, meaning do they have orientations in all different directions, which you might expect from thermal cracks? Or if they are developed due to ice-coast interaction, maybe there's some anisotropy in them that would impart an anisotropic behavior in the stress-strain relationship. So essentially, we are measuring strain, which is horizontal deformation, on scales of tens of meters to 1,000 kilometers across the whole Arctic basin. So everything is nested, embedded. And then we want to understand what the internal stress in the sea ice is doing. Now, this is the tricky part because we can't actually measure the stress around a boundary on the scale of a flow or multiple flows. It's impossible. So we can't do what you would normally do in the laboratory, where you're trying to design a constitutive relationship for modeling the sea ice mechanics, because we simply can't make the measurements that are needed. So what we have is a measurement of stress with vibrating wire strain gauges at points throughout on the flow domain scale, the flow, and we spread that across the multi-year ice and the first year ice. And the concept is we're going to use models, especially discrete element method models, Lagrangian models, to constrain with the observed stress to understand how the heterogeneities in the ice are actually affecting the stress field, and trying to actually predict where we might see cracks forming. So to start off with, we have remote satellite support. This is a set of radar SAT-2 images that were provided by the National Ice Center, and we can track how the ice is moving in time along the coast of Alaska up here. North is pointing down this way. The camp is the red dot. And you can see leads opening and closing around. So we will have a bunch of ice dynamics tracking kinematics products coming out of this group at the University of Delaware. Thank you, Kelsey, for that. On the ice, a lot of assets were deployed. The radar, I think Emily is much better positioned to talk about that, but we're tracking very small scale ice motion with the radar. And then we have very coarse resolution ice motion checked with straightforward GPS. This is Emily, thank you, Emily. And a SAT-ICE buoy, which is basically a high quality geodetic GPS. And it had accelerometers on here that Pedro from MIT has deployed. And we deploy these in an array around the camp. And this is overplotted on a WorldView 3 image, which has incredible resolution. And you can see the cracks and leads that formed in the ice at the time of this image. So we're tracking the motion around the camp. This is over 3 weeks periods with the SAT-ICE buoys. From that, we can get at the horizontal deformation. And nested within that, we actually had a series of higher resolution measurements. So we have a dense measurement region, and there's this range in here, which I'll call the seismoacoustics range, which was led by Woods Hole and Erin Fischel, which is looking at using geophones and hydrophones to triangulate where the ice was cracking. I don't have a map of the sensor array because, as I said, the field party has just come back from the field, but this was the philosophy that we laid out across an area of multi-year ice, which is depicted as gray on this cartoon, and first-year ice depicted as white on this cartoon. So a very dense array of stress sensors, which are the S's, and bounded on either side of stress sensors with strain measurements, which were accomplished by using a robotic theodolite, 3 of them actually, and laser targets for that theodolite. So this is fairly standard methodology that's been used in the past on sea ice surveying, but making use of modern technology so that we can do this efficiently and get a measurement of strain with centimeter precision on a grid around the camp for 5-minute time resolution. The seismoacoustics range had hydrophones and geophones laid out like this with a dense cabled array in the center. And we've seen quite a few events detected in the channels of this, this range. This one here is particularly interesting. So this is essentially the number of sensors that were triggering was seeing an event. We have a threshold for defining what an event is in this plot. So on March 11th, March 10th, March 11th, the camp was moving northward and then did a reversal in its track as it pushed up against the main pack. And at that time, we actually see a lot of activity in the acoustics. And if we look at satellite imagery collected after that event, you can see that there was 2 cracks, one here and one here, that had existed for many days beforehand, and they were joined together by more cracks as this ice pack sheared across that shear zone between those 2 leads. So it's the first time I've actually seen this happen, and I always wondered why, when you're walking around the ice pack, you see these cracks that are at almost orthogonal directions to each other. This is an example of how that happens. And in the acoustics, we're actually very clearly seeing that signal of that breaking. So this will be quite fun to look at because we'll be able to determine if we're seeing them from the same direction. So that's future work to happen. We We actually saw a lot of activity at the ice camp, and here's another example of on the 14th of March, we actually saw a crack that ran through the seismoacoustics range. That's this one here. And you can see a lot of breaking that was occurring after that. This lead down here is the one that had been active throughout the whole period. And in the SAT-ice buoy data, we can clearly see that lead opening associated with that event, and then ridging. Notice how you've got this ridging has a periodicity to it, almost kind of chaotic periodicity, but it's holding steady and then ridging and closing, holding steady, ridging and closing. It's classic. We can also see that in the acoustics data, and Erin calls this popcorn sounds, which is pretty cool, but it's most likely stick-slip motion related to that ridge building. So we're going to have a bit of fun untangling all of this and understanding what we're looking at. So to finalize, this is really just a flavor of what we're getting from this field campaign. It's pretty exciting. I can't wait to start playing with the data. But the events that we're seeing in the data so far is we're definitely seeing thermal cracking, and we're seeing failure due to wind loading. So we're able to actually determine which wind loads and ice-coast interaction is causing the breaking, which has not really been possible in the past. We're seeing ridges accumulating strain. We're also seeing new cracking. So some of the things that this data set will be used for examining is looking at the process of crack enucleation. So those large scale cracks that propagate across the whole Beaufort Sea, what's actually happening on the scale of the ice flow itself as the ice is breaking at the crack tip. We'll see the role of pre-existing flaws in the ice pack and how that affects the strain response to loading. Is there any anisotropy? And we're actually tracking those flaws, so we know when they've formed and the history and evolution of the ice flow afterwards. And we're investigating the accommodation of stress in the ice pack or scales on the scales of the flow all the way across the shear zone and into the larger scale of the Beaufort Sea. So essentially, this is giving us a data set that's pretty comprehensive for getting at some of the fundamental questions of at what scales do we need to employ an anisotropic sea ice rheology in our climate models or in our sea ice forecast models? And is, for example, the Bill Hibbler isotropic model actually applicable at any scales? These are the large questions that we will be hoping to answer. And so I'm actually really looking forward to conversations with sea ice modelers on how we can work together to make use of this data set that we've collected. And I would hope that my 5-year vision is that we will be able to inform the next generation of sea ice models, and maybe the National Ice Center will have a forecast model in 5 to 10 years from now that will be even better than the one they have now. So forecasting ice drift is something that's needed for supporting safe operations in the Beaufort Sea. Thank you very much.
Thank you, Jenny. That was a really nice talk, and I'm impressed by how much information you're able to pull together, especially since they just got off the ice last week, I guess it was. So thank you. It's really exciting. I'd like to open it up for questions, especially you mentioned how can these observations be used for modelers. So does anyone want to raise their hand or unmute themselves to ask a question? And you can also write a question in the chat. Yes, Sinead, you have your hand up.
Hi, I do. Sorry, I'm almost hoarse. Sorry. Hi, Jenny. Hi, Melinda. Great talk. Really fascinating. Just a quick question about the wind events that caused the initial cracking across the Beaufort and the arch setup. Was that due to just one cyclone or like one pressure system, or were there multiple pressure systems while you were on the ice? Just sort of the connection with the weather.
Oh, yeah. Okay. So I'll be honest, it was so long ago, 3 weeks ago, when we saw that setup with the arch. I've totally forgotten what caused it, but we had a high pressure system.
High pressure. Sorry. Okay. Okay.
Actually, what happened since then is pretty interesting, because we had a lot of mid-latitude cyclones move into the kind of East Siberian sector of the Arctic. And those caused us to have easterly winds in the Beaufort Sea. So even though we didn't have the classic Beaufort Gyre, the Beaufort High setup, we still had very fast winds moving the camp to the west. That was actually what caused that bunch of large leads to form across the whole Beaufort Sea. And that happened after the initial setup, where the ice was being packed, was pretty stationary with an arch to the front of it.
Mm-hmm. Okay, thanks, Jenny. Thank you.
Yeah, it was exciting to watch. It was nerve-wracking, to be honest.
But yeah,
especially with 6 people on the ice in 2 tents.
Yeah, but they got back okay.
Fine, yeah, they did an amazing job. I can't tell you how amazing it was.
Good. Thanks, Jenny.
Oh, that's great. We have lots of questions in the chat, so we'll just go in order here. Ula Pearson asks, was there any atmospheric forcing during this ice cracking ridging event, such as fronts, etc.?
Yes, we actually had some really interesting atmospheric dynamic setups that were affecting this. So we had some of the cyclones, 2 of the cyclones would bring a front across the north slope of Alaska, and there was appears to be a topographic effect where the Brooks Range actually pushes the pressure contours together, and that ice drift was actually accelerated because of the increased wind speed, I think. There was a lot of space for the ice to move into. So it was almost like it was moving in free drift for part of the time. I don't think we saw any fronts moving directly across the buoy array, maybe once, but that front was more to the north. But that's something I will definitely pull out from the data once I've got time.
Great, thank you. And we have another question from Robert Newton. Are you measuring the impact of sea ice drift shear on vertical motion and or heat flux in the water below?
So we do have vertical motion from the SIDEx buoys. Unfortunately, because this was a very small experiment, as I said, there's 6 people on the ice, we're lacking any information about the ocean, and all we had for the atmosphere was a very simple weather station with anemometers. I would have loved to have been able to do this on a larger scale, but actually when you see that we were pretty close to the coast, we're like 70 nautical miles away from the coast, the idea was to be able to evacuate the camp in one go, in one plane load, because we knew it was going to crack. And so having a lot of assets and a lot of people out there to run an oceanography program might have actually been quite dangerous. I do see an experiment about a question about how this is different from Mosaic. And that's one of the key differences, is Mosaic has all of this information of context on the forcing that's being applied to the ice and causing the breaking that we're seeing. The experimental design on Mosaic was a little different because we didn't have the SIDEx buoys, so we had a more limited set of measurements on the higher resolution strain. But we do have some information about internal ice stress, and we know where the ice was breaking and ridging in relation to those stress sensors, and we have a very good observations of strain rate from the ship radar. So essentially we could use the Mosaic data set to do something similar to this experiment, but we're not actually able to resolve exactly when the ice was cracking, which is the difference with the SIDEx field experiment.
Great, I'm glad you touched on that point and the linkage with Mosaic. I think we have time for one more question before we move on to the next update from Walt. And if there are more questions, we can also circle back to this discussion. And this question is from Bjorn. You have your hand up. Do you want to ask it?
Yeah, well, do you hear me?
Yes.
Okay, thank you. Thank you very much, Jennifer. There are several questions. Maybe I'll discuss those on a different manner in different settings. First one was on the cracking geometries, as I'm coming from that inclination. But did it appear that the cracks were seeing or sensing the different ice types? You had a multi-year there, or did it just go through and meaning did the different ice types appear to have impact on the crack geometry? That was the first. Then there are several other questions, technical, I'll take it later, but that's an interesting one. Thank you.
That's a good question, and honestly, I have not had enough time to look through all the imagery and answer it properly. My impression from just watching the camp flow break up, which was quite dramatic, actually, is that it didn't care for whether it was multi-year ice or first-year ice. What was more important was the camp got caught between two leads, and it was across a shear zone. And when there was a stress imparted in that shear zone from either the north or the south, as the ice pack moved north or moved towards the coast, I think we saw cracks that were going in directions that were defined by that motion, that shearing motion. And it would be very hard to determine. I don't know yet if there were pre-existing flaws there, because we need to look through the data set, and that would be something that Chris would be very interested in looking at, that defined exactly where it was cracking. But what I can tell you from looking at the world view imagery is once there was a crack, it would work. So once I can see something on a scale of 1 meter or 2 meters, so now we're talking not about thermal cracks, but about dynamically formed cracks, then they would work. So we were seeing that, but I think that the geometry was more defined by the boundary conditions than the fabric of the ice itself. That's my impression.
Thank you.
Hey, thank you. I think we should probably move on now to the next speaker. And if people still have questions, you can put them in the chat. And at the end, we can circle back to these questions, or Jenny, feel free to respond to them in the chat as well. So, okay, Walt, are you ready?
Yeah, sure.
Great.
So I'm not going to take too terribly long, but I just wanted to touch on some of the data that we were providing the SIDEx mission. You know, the U.S. National Ice Center, we do many analyses, both for ice and for snow, that serve the numerical weather prediction community modeling. Some of them are used for climatologies. We have some partners that build climatologies for ice from our daily and weekly products. But you know, the other bucket of things that we do at the U.S. National Ice Center is tailored support or decision support services to people that are operating either within the ice, such as an icebreaker, or people like SIDEx that are operating on top of the ice. It was kind of nice for once to have an ice camp where a breakup was anticipated and almost being looked forward to. Some of the other ice camps that we deal with absolutely under no circumstances want to see the ice break up, and there's not much we can do about it when you know, the Beaufort climatology takes hold in the late winter and early spring periods. But so, you know, when we get these kinds of requests, one of the things that we do is we're kind of fact finding about what is needed from the group. Is obviously the geographic area and trying to understand the imagery that is both needed and is available to the group. So I know one of the core things that we were providing to SIDEx was synthetic aperture radar imagery, particularly RadarSat-2 imagery. And so what we can do when we have these kinds of things is we can kind of put out a notice to the person who's ordering our imagery that there are people operating in this area, and maybe we can gain some extra collections of SAR. You know, typically in Alaska, we're already taking as much data as we can possibly get when it comes to SAR. But that is one aspect that kind of takes place when we get these requests. So we were able to order RadarSat, and I believe those images were placed onto an FTP for SIDEx to use at their discretion. There were two other sources, or two other kind of data streams that we were providing to the SIDEx team. One of them was International Arctic Buoy Program data. So this is the kind of network of buoys that is there for not only research purposes, but they also go into numerical weather prediction themselves. And the U.S. National Ice Center is, kind of both an end user and a stakeholder in IABP, and in trying to ensure that there's good coverage of buoys across the Arctic. So as both an end user and a stakeholder, we utilize that data on site, and we help it to advise our products, and we also pass it on to our end users, such as the SIDEx team. So I believe that they were getting some shape files, possibly of IABP data emailed to them, so that kind of gives them, obviously they have so much more instrumentation on their small scale, but that also gives them another data point as to what's happening on the more kind of mesoscale or synoptic scale surrounding the ice camp. And then the last thing that we were providing was model output layers. The model that was utilized for this was GOFS. It's developed by NRL and I believe currently run by Fleet Numerical. But we were providing both ice concentration and drift vector data from the GOFS model to the SIDEx team. And really, these kind of three things in tandem, the imagery, the buoy tracks, and the model output, is to just try to help them kind of keep that 10,000 foot view as to what's going on in the region, and try to give them a little bit more data that helps them create a more complete picture of the situation. And I hope that it was of use as well when it came to kind of finding the camp and IDing the area that they wanted to be in, and maybe seeing some of those features that they were looking for before they even kind of deployed out their entire camp. So that is all I have, but I'm happy to take questions as well, and I will answer them to the best of my ability.
Great. Does anyone have any questions that they'd like to ask?
Can I add a brief comment on the utility of the data that Nick provided? So we would not have been able to have found our camp flow location if it hadn't been for the RadarSat-2 support. And the map I showed in my presentation of where the camp was the first view that we had of what the ice types were around that campsite. So this is, vital support for any field campaign in the Beaufort Sea at this time of year. It's just not possible without getting that data in near real time. So thank you. And I also used the International Arctic Buoy Program shapefiles because they're very useful for overplotting in GIS. So you can get a very quick view of what's going on around you. Whereas working with the International Arctic Buoy Program raw data, which I will do in the future, is a little more clunky to work with. So it's a very nice product to just get a snapshot of what's going on. So thanks.
Yeah, and I want to add that, it's a collaboration. It comes full circle, right? Like you were alluding to, Jenny, I can only hope that some of the results that you all garner from this particular exercise will help better the models, will help us get a better understanding. So both NOAA's modeling community and people like NRL can better understand deformation and strain within the ice. And we, like I alluded to, we have users who are very concerned about ice breakup with their camps, because that's not what they're there to study. So hopefully in the future, this will also inform us to better analyze and assess and model, basically leads, cracks, and other deformation features in the Arctic.
I agree. That would be exciting if we could actually give you a map of where to expect pressure in a forecast, because that would be equating to where you would expect new cracks to form. I think that's something to work for in the NRL model down the line. Thank you.
Good. And I want to put some of the modelers on the spot here. And can you see how these observations will be useful for making model improvements or assessing your models? I think Richard Allard's on the call. Are there any others who'd like to speak on this point?
Yeah, Melinda, yeah, that was a great presentation, Jenny. Yeah, certainly we'd love to look at your data when it becomes available. We know we have shortcomings in our system. You know, we're working closely with folks such as Los Alamos as they're making improvements, you know, to the SIDEx model. And as you said, you mentioned this discrete element model. So there's a lot of different approaches out there that we certainly want to investigate further.
Thank you. And you did ask a question before. Is there more fieldwork planned for next year? I don't know, Jenny or Walt, if you want to address that question.
Oops, I answered that question in the chat, but I realized it went to Devin O'Connor rather than Rick, because there is not more fieldwork planned. This was the last field season for SIDEx, but there is a possibility in the future that we might need to do some more fieldwork on landfast ice, essentially understanding the how the cracks are propagating on the scales of centimeters to meters is something that could be done in a landfast ice experiment. And there is possibilities there, but I don't envision a huge field campaign with another field campaign with an ice camp for the foreseeable future. They're very expensive to run.
Sure. Well, thanks, Jenny.
Can I raise a question here?
Yes, go ahead.
Thank you. There were two questions. One is how many stress buoys did you have there, and likewise the stick slip events that you recalled or registered. Were they associated with ridging? And my question: how big were the jumps in the stick slips compared to the overall loading or the loading amplitude that you had there? So those are maybe too technical, and I think you will get from the stick slip behaviors a notion on the cohesion strength and the friction as well. So there's a lot of information in this data. Likewise, the scaling in time and space comes out of it, and hopefully some stochastic variable on the fracture. I don't know how, but it must appear in the data at the end of the day sometime. A question to Walt was, what is the resolution of the consecutive imagery you had over radar imagery that you had over there? Were it daily or many per day or in space and time? What can you give some numbers there? Thank you. There was questions to both of you, Jennifer and Walt. Thank you.
Walt, do you want to go first? I'm not hearing Walt. Oh, there you go.
Yeah, I'm not really sure what to say. Jenny, I'm going to let you take that one.
On the resolution of the models, I think I might have, yeah. Okay, so I'll start from the beginning. Full disclosure, I'm guessing these are stick slip events based on the periodicity that I was seeing for the popcorn sounds in the acoustic data, which is of the order of minutes, which is, so you see stick slip behavior in sea ice when two sheets of ice move against each other. And if you actually were to watch a ridge moving, it tends to move and then stop and then move and then stop and move and then stop. And the periodicity of that can be the order of minutes to 10 minutes. And then it will work for maybe an hour and then it will stop. So I'm just guessing that's what we're seeing in the data set right now. I think we need to do a bit more work to tie it together, but there is coincidence between when the ice was ridging and ridges actually formed and what we're seeing in the stick slip motion. And in terms of how that impacts our estimates of cohesion, it's actually telling us something about the frictional losses in the ridges. So there's a group at the University College London, Samuelson's group that's done some work on stick slip motion in sea ice, and there's potential that they could improve models on that, which really is telling us about the frictional losses due to ridging. But this is only one kind of way that strain is being accommodated in the ice pack. So when it's closing and ridging, we're seeing this behavior. But the contrasting example was when we're seeing opening and cracking. So we have to think, I'm thinking it's important at this stage to look at the process mechanistically to understand the energy balance that's involved. And in terms of the resolution of the models, well, that's kind of a key question. It's what is that?
No, I was just on the imagery. The models, they are kind of lost in the loading with the resolution and the computing power that they can.
I couldn't speak to the worldview imagery, but our synthetic aperture radar that we're providing is typically the coarsest it will go is about 30 meters. I'm not exactly sure what beam modes were ordered to support SIDEx, but at its coarsest, the radar sat is about 30 meter pixel.
Yeah, so we were working with 20 meter and 50 meter resolution radar sat too. And the worldview imagery, you have I think it's a 10 kilometer scene with 1 meter resolution, pixel resolution essentially.
That's huge. And the timers, how frequent were they?
Oh,
passes?
well, now I have to have a huge thank you to the USGS who actually helped manage us. We managed to collect 3 or 4 scenes a week over the last 3 weeks, which is unprecedented for this imagery. And part of that is because of Nick Wright's amazing website where he put on an ice drift forecast, which wasn't actually using a model. It was based on Topex winds. So it was a simple rule of thumb, ice follows the wind forecast. And it worked pretty well when we were able to expand the sites that we were expecting to collect imagery over based on our understanding of how much faster or slower that forecast might be than reality. So it was, we had remarkable success on that, and I'm really thankful to Andy Breton actually Andy Breton at the USGS who put a lot of work in to make that happen.
Thank you. Exciting. Yeah.
Great. Does anyone have more questions they'd like to ask while we still have a few minutes left?
I have a question for Emily if she's still on the call.
Yes, go ahead.
Emily, what was it like out there? How cold was it? It looked like the coldest field campaign I've ever seen.
It actually wasn't as cold as I was expecting it to be. Like the first couple days were like -30, -25 and below, but after that it was probably, I don't know, -15 or -20 and above, and had some windy days which made it feel colder, but also had some gloriously sunny still days that were amazing, and everybody was outside. You're like, we should get everything done that we possibly can today because the weather's gorgeous. No, I felt like we had really great weather for it. I think we were definitely warmer than in Dead Horse. My dad was reaching me, asking me about the weather and looking at the weather forecast in Dead Horse and thinking it was colder than it was. But
always different in Dead Horse. Yeah. I'm excited to see your data when it comes out. See what you get out of it. Thanks.
Yeah, I think we got some good data. Thank you for the presentation. It was awesome to see the beginnings of things being synthesized together and from all the little parts that have been collected. It was really cool.
Yeah, I think being on the ice, you didn't get to see how excited the PIs left back home were about the data they were seeing.
No, so this has been really cool.
Thank you.
Thank you.
Yeah. Welcome back, Emily. You had a group of fans cheering for you in the field.
Thanks.
Since we have a few minutes left, I do want to open it up for any community updates, any upcoming meetings or workshops people would like to share with the community while we still have time.
Hi, yes, this is Meredith, and I wanted to share an IARPIC update. So I'm going to put in the chat box a link, and this is a link to information about the draft Arctic research plan for 2022 to 2026. It's currently publicly available and open for comment in the Federal Register, and other ways to comment as well, which are listed through that link. So we encourage you all to look it over and consider especially how the SIDEx team might fit into this pretty different structure for the Arctic research plan in the coming years. And I'm sure that the co-leads for this team will make space over the next coming months while the plan is open for comment for the team to consider and provide comments here to the team leaders, and also to think about how the team might move forward. So just wanted to put that out there as a topic for future discussion and to let everyone know that that plan is out.
Thank you, Meredith. That's fantastic. And I'd really encourage everyone to have a look through that draft plan, and please send us feedback if you'd like. It looks like there is an update about the 2020 SIDEx Outlook. The postseason report was published last week, and there is a link in the chat for that. Betsy, do you want to say anything more about that?
Just many, many thanks to all the folks on the SIDEx Prediction Network 2 team that helped write that, and also to Helga Gerslin from SIDEx. And it's a pretty dense report. It's worth review. It's obviously late in the season, but with a combination of challenges that have come up with the pandemic, we're really happy to have gotten that out. And many thanks to the ARCUS staff who helped get that out last week. It's a good report. I hope you take time to read it.
Great, thank you. We really appreciate that update. Does anyone else want to give an update to the community here?
Betsy, this is Mike Steele. Can you hear me?
Yep.
Yeah. So I just want to add to what Betsy just said. So I'm part of SIPN now too, and we're going to, for this year, 2021, we're going to ask for something a little bit new in addition to what we usually ask for from the modelers, and that's we're not quite sure exactly how we're going to do it, but we're going to more or less we're going to ask for some kind of measure of anomalous forecasting. So the idea is that SIDEx modelers, all the models have biases, and so the spread in the predictions is a result of many things, including the bias of the models relative to each other. And so we're trying to at least get rid of that or deal with that. And so we're going to ask for some kind of forecast relative to your mean state in some way. And so keep an eye out for that.
And additionally, we will be asking also for an outlook for September, for early September, based on May, June, July, and August data. So there are a couple new things coming for the 2021 SIO solicitation. Keep posted, and we'll get those out on both the SIPN network and announcement on IARPIC as well. Thanks. Thanks, Mike.
Fantastic, thank you both. Are there other updates people would like to share? Okay, if not, thank you all for attending today. It was really nice to see you, and I really appreciate the discussions. It's fantastic to see the connection between SIDEx and Nick. So thank you all, and thank you, Jenny, for giving us your time today and sharing your insight and perspectives on that field campaign. We really appreciate that. Okay, have a good week, everyone.
Thank you very much.
Thank you.
Bye-bye.
Thank you.
Have a
Bye,
good day, all.
everyone.